Good morning, Miss Barbara.
I hope everyone is having a splendid day. Absolutely splendid. All right. You ought to see the paper version of our practice exam on the left and note paper on the right. And let me move this so I can see the numbers, the problem numbers. And I now leave it up to you. What questions would you like me to go over? I sent everybody a copy of this yesterday. Silence. I thought I was doing you a favor. Well, in lieu of any requests, that's hard to say. I'll just start here with number 1. A function a of s given by a of s equals 0.285s plus 60 can be used to estimate the average age of employees during the years 1981 to 2009. Let a of s be the average age of an employee and s be the number of years since 1981. So that s equals 9, and s equals 9, using that system, would equal 1990. Because we're looking at years after 1981, so 1982 would be year 1. Yeah, it's weird, but 1982 would be year 1. Because it's 1 year after 1981. And so using that system, if s equals 9, that's 1990, and now we're going to find the average age of employees in 2003 and 2009 using this. So while this seems like it's going to be hard, actually the only hard thing is to figure out what the years 2003 and 2009 would be using that system, where we're looking at years after 1981. So using this system, 2003 is year 22, which I've written in yellow, and some of you might not be able to see that, so let me rewrite it in black. But if you can see my yellow highlighting or underlining, I think it's good to go through these word problems, read them several times, then start underlining what you realize after you've read it a few times, what you realize is the most important part. Okay, well, if 2003 is year 22, because it's 22 years after 1981, and 2009 is 28 years after 1981, then what you do is you find a of 22 and a of 29, 8. I have no idea why I do that. And so using this, we would have 0.285 times 22 plus 60, and this would be 0.285 times 28 plus 60. And you put this in your trusty calculator. So let's do that. I should have called up the calculator. anytime now. And I want to know why I can't. Ah, maybe because oh well. Okay, so 0.285. 0.285 times 22 plus 60 gives us 66.27. And so what we need to do is look at, you should always look at what this says underneath. On MyMathLab, those instructions underneath the answer box are blue. Read them so you know how to answer. If you put the answer we got, 66.27, pretend it's there. If you wrote this, it would say you're wrong. And you would think that, well, you would punch the wrong buttons in your calculator, but you didn't. You just didn't round it to the nearest whole number, okay? Which means no decimal points. So I'm going to erase there. And that's how they end up with around 66. It's what you need to do if this problem is on the test. Okay, now, so we calculate this the same way. Let's see what we come up with. 0.285 times 28 plus 60, enter. And we get 67.98. Well, we're supposed to round to the nearest whole number. The whole number part of this, the whole number part is to the left of the decimal point. But this 9, which is right next to the 7, will cause the 7 to go up to an 8. Which is how they get 68. So it's a good idea, something to help you get problems completely right as opposed to partially right, would be to review your rounding, because it is important. In fact, the higher you go in math, the more important rounding gets. Now I can keep going in order, or you can ask me to do particular questions.
Can we go over number 15, Miss Barbara?
Sure. Number 15 and Gonzalez Manufacturing. Yes. Okay. There it is. All right. Well, we need the whole screen, I fear. Okay, or not, or even more than the whole screen. 15, Gonzalez Manufacturing borrowed $36,000. Oh, I remember this one. I wonder if the highlighter will work now. No, it just has not been working. All right, I don't care. Let's go do orange. All right, so they borrowed $36,000. And part of this money was borrowed at 10%, some at 12%, and some at 14%. All right, the annual interest is $4,400. And the total amount borrowed at 10% and 12% was twice the amount borrowed at 14%. Use Gaussian elimination to find the amount borrowed at each rate. Okay, that means set it up like a matrix. So I am going to come over here and use scratch paper. My scratch paper. And the way I would do this, even though, I've done similar ones, is to take notes on it first. They borrowed $36,000. And the annual interest that's how much they're going to pay for that $36,000. Is $4,400. Okay, and they're borrowing at interest rates . 10%, 12%, and 14%. And I'm going to double check that to make sure I've got that right. 10%, 12%, and 14%. And then we're given another fact. And that is that the money borrowed at 10% and 12%, the total amount borrowed at 10 and 12%. Is twice the amount, twice the amount borrowed at borrowed at 14%. Okay, and I'm going to put a line between our
And
total
that just
borrowed.
means, does that just mean that, so what we end up getting for 10 and 12% is like, okay, so what we get for 10 and 12, the sum of it is going to equal 14%?
2 times the amount at 14%, yes.
Okay, 2 times the amount, okay.
So let's look at this. Let's start breaking this down. First, we don't know what those amounts are. We're supposed to find those amounts. And since we've already been told to write this as a matrix, because you're not going to use Gaussian elimination on anything else, let's say, since there are 3 amounts borrowed, 3 different interest rates, let's say that the amount I've got all my stuff here. So the amount borrowed at 10%, let's let that equal X dollars. And the amount borrowed, I'm not going to write all that. The amount borrowed at 12% is Y, and the amount borrowed at 14% is Z dollars. So we've got these three amounts being borrowed. The total amount borrowed was 36,000, so it has to be that X plus Y plus Z is 36,000. And then it also has to be I'm laughing at my cat. No, just anything. Give me attention, give me attention. Don't talk to them, talk to me. What can I say? We're going to change the percents here to decimals because you have to do that when you're calculating. So we also know then that if we add up the amount of the interest, I can't concentrate, please. Point 10% X, that's the total amount borrowed on the X dollars, and I mean the total amount paid back, the interest. So the total interest paid on the X dollars is 0.10 times X. So that's how much they actually have to pay for it. 0.12 times Y is the interest they pay on the Y dollars, and 0.14 times Z is the interest they pay on the Z dollars. So these three amounts, these dollar amounts, there you go. These $3 amounts are the total interest paid for the year. There, so we know this. And now we know one more thing. Thanks to this, the total amount borrowed at 10% and 12% is twice the amount borrowed at 14%. So I could say, okay, well, the total amounts borrowed at 10% and 12%, that would be X plus Y, is going to equal twice the amount borrowed at 14%. However, that's not the way you write a matrix. There aren't any letters over here. So I'm going to have to subtract 2Z from both sides, so that I get a 0 over here. And so that's my basic matrix, but I am going to do one more thing. And that is, I want to get decimals going here, okay? I mean, I want to get rid of the decimals. I want them to be going, gone. The way I can do that is, since I need to move the decimal point over 2 places, is I can multiply this entire line by 100. When I multiply 100 times 0.10, that'll be 10. And when I multiply 100 times 0.12, that'll just be 12. And when I multiply 100 times 0.14, that will be that'll be 14. Yeah, and it's going to make 4,400 a lot bigger too. Okay, so our system then is going to be, let's do this first. We're going to have 10x plus 12y plus 14z equals 100 times 4,400. That will be 4,400 with 2 more zeros on it. Move this over. Meanwhile, 1x plus 1y plus 1z equals 36,000. So 0, 0, 0, 36. Let me write that better. Let me write both of them better. Okay. 36,000. And that's 440,000. Because we had to multiply 4,400 by 100. $440,000 and 1x plus 1y minus 2z equals 0. And now we are going to make a matrix from that. So matrix 1 and I admit, I think I said this last time, I said you could do this more quickly, not using a matrix. Well, I did it and it wasn't quicker. It was more interesting, but it was not quicker. In fact, it was really dangerous. So I highly recommend sticking to the matrix form. 1, 1, 1, 36,000. And 10, 12, 14, 440,000. And 1, 1, negative 2, 0. And that looks too much like an 11. There, that's better. All right, row 1, row 2, row 3. And we're going to use row operations and make sure that that is there waiting. But I can't stand it being so big. There must be a better way. Excuse me a minute. View. I just don't like it. I don't like it. Well, it appears that it doesn't matter if I like it or not. Okay, fine. I am going to, initially, you almost always, like 99% of the time, are going to use row 1 and row 2 together. And you're going to find a way to zero out that place right there, that location. So how I'm going to do that is this. I propose to take negative 10 times row 1 and add it to row 2. And that will give me negative 10 plus 10, that will equal 0. That's all that matters, is that I get a 0 in the first position. So, negative 10 times 1 is negative 10. Negative 10 times 1 is negative 10. Negative 10 times 1 is negative 10. Let me write this here. Negative 10R1. Negative 10 times 36,000 is negative 360,000. And just R2, or remember that some programs require you to put a 1 in front of the R2 if you're not going to multiply it by some other number. That will give us positive 10, positive 12, positive 14, positive 440,000. And we will, negative 10 plus 10 is 0. Negative 10 plus 12 is 2. Negative 10 plus 14 is 4. And 4,400 minus 440,000 minus 360,000 is $80,000. Double check me and make sure that's right. This is going to be my new row 2. So I'll come down here to write matrix number 2. Yeah, that's right. Okay. Matrix number 2. I'll have R1, R2, R3, and I want to write this before I write anything else, just to make sure, 80,000, I don't forget. And I'll copy this the way it is, 1, 1, 1, 360,000. And then row 3 is 1, 1, negative 2, 0. Okay. All right, there we are. Now, when it comes to matrix 2, you're going to be working with row 1 and row 3. And your goal is going to be to put a 0 in that position, the red position. Well, to do this, it looks like it would be easiest to take row 1 and add it to negative 1 times row 3. So I'm going to do that. Okay, that'll be 1, 1, 1, 360,000? No, I am glad I looked at that. It was temporarily 360,000 here, actually negative 360,000. But we go back to the original line 1, that's 36,000, not 360,000. Okay, phew, that's good. Now, -1 times row 3 will be what? -1, -1, +2, and still 0. 1 minus 1, or 1 plus -1 is 0. 1 plus -1 is 0. You are kidding me. Woo! 1 plus 2 is 3. And 36,000 plus 0 is 36,000.
I have a question.
Yes.
So I know that you multiplied row 3 by -1, but could you also have multiplied row 1 by -1?
Yes, you could. Absolutely.
Okay.
Good
Because,
thing.
yeah, that's usually how I do matrices. Whenever I'm trying to solve, like we're trying to solve for row 3, I usually try and manipulate the other one so that I wouldn't have to manipulate that one.
Okay, that's great.
Okay. But we did get different answers.
Well, right now we did.
Okay.
What did you get?
I got 0, 0, -3, and -36,000.
They're not really not the same.
Okay.
We're gonna get the same answer for Z.
Okay.
Now, as it is, you have been saved a step. That doesn't always happen. It's kind of nice. I'll show you how. We're only going to have 3 matrices this time rather than 4. It's normal to have 4. But the reason we don't need to have 4 is that we were given our 2 zeros there right away. So that was like 2 steps in 1 step. Okay, now we're going to use this 2. Row 2. Okay. Now, I'm going to change this back into a system using X, Y, and Z. There's our system. We can now call this, if we want to, line 1, line 2, and line 3, or equation 1, equation 2, equation 3, doesn't really matter. And the first step, I'm going to start back solving. I'm going to do my back solving down here, just because this is where I have room. I'm going to start with line 3, or row Z, or row 3. 3Z equals 36,000. I'll divide by 3, divide by 3. 3's cancel over here. I will have Z equals 12,000. And I bet you got 12,000 also. Now I go back.
I have one more question. I'm sorry.
Sure, no, don't say you're sorry.
So in our beginning, whenever we were trying to solve the matrix, so line 3 was 1x plus 1y minus 2z. So what happens to the 2z?
We had used it here. 1x plus 1y minus 2z equals 0.
Oh, so it just changed.
Yes.
Okay. I'm just trying to
Good
like
thinking. It's good thinking. All right, now, so we worked on line 3. Now we're going to go to line 2 and substitute. Okay. Okay, this is going to give us 16,000. The reason I'm not putting commas is MyMathLab used to not accept commas. Your calculator, you don't put commas in that. There is a comma, but it's used for something else. So Z is going to be $12,000. And Y is going to be $16,000. And now we take these two amounts up to row 1. I'm going to put 16,000 in here. And 12,000 in here. Now, we could use this line right here to solve for X, or we could have said, well, wait a minute. I know that X plus Y equals 2Z. And so X plus 16,000 equals 2 times 12,000. And so if I subtract 16,000, well, I shouldn't do that yet. Never mind. This just might be a little faster. I honestly don't know. Okay, 0, 0, 0, 14 minus 6 is 8. So I get 8,000. Yeah, that would be right. Okay, so X is going to equal $8,000. X is going to equal $8,000. and Y is going to equal $16,000, and Z is going to equal $12,000. But if you don't feel good about that, you could go ahead and use this line. 16,000 plus 12,000 is 28,000. You would subtract 28,000 from 36,000. And you would still get 8,000, that X equals 8,000. So would that be faster? It might not. It might actually have been faster to just go ahead and do this and not use this other little relationship. But you see, either way, you're going to come out with the right answer. It's all in the steps. And sometimes when you're given 2 steps at once, don't say no. It just saves you time. We normally would have gone to another matrix and used row 2 and row 3 together to put a 0 in that position, but we unexpectedly got 2 zeros at once, here and here, so we didn't need to take that last step. Let me save while you cogitate. Oh, okay. There. I am more than glad to take questions. Memorize the methods, but not the answers, because usually everybody gets different numbers when they're taking the test. It's rare that you would get exactly these numbers. It would be the same problem, but not the same numbers. And what number was this? 15? Myra, are you there? Am I there? Yes, I am. Okay, well, I am going to open up this and go back to my MyMathLab. No, that's the wrong step.
Could we do some finding domain?
Sure, let's look for one. Let me make this smaller, it's really annoying me. Not that small. Okay. Here. How about this?
Sure.
Okay. We end up being asked for the domain of this. So let me make it blue. Just so I can try. Now this might or might not work. Well, best I can do. Yeah, we've got this blue line that has open circles at the end. And here's the matching domain. The domain is always on the x-axis, and the range is always on the y-axis. And so this is the part of the x-axis that goes with the graph. And this is the part of the y-axis that goes with the graph. And for that reason, the green line is the domain, and the kind of reddish purplish line is the range. And so the open lines means, well, if you come over here, look at the green line. It has an open circle at each end. And so what that would mean in set builder notation is this: all x such that x is between -6 and 2, but does not equal -6 or 2. And then if you were writing it in interval notation, you would write it like this: parenthesis -6, comma 2, parenthesis. Now for the range, the lowest number is -4 and the highest number is 2, and you always put the lowest number first and then the highest number. So in set builder notation, you would have all y such that y is between -4 and 2, but doesn't equal -4 and 2. And in interval notation, you would have parentheses -4, comma 2, parenthesis, because parentheses means y cannot equal 2, y cannot equal -4. Here parentheses mean x cannot equal 2, x cannot equal -6, but all the numbers between -6 and 2, and all the numbers between -4 and 2 are in the domain. So all of these numbers are safely in the domain, and all of these numbers are safely in the range. It's just the end points, the very, very end points that are not there. Now, along with that, they're asking you, what is f of -2? And to find this, you go to, because this is always x right here, always x. You go to x equals -2, and then you come to the graph. And then over to the y-axis. And that tells you what the y coordinate is there. So this point is -2, -1. Or the function, which is the line, at -2 is -1. And down here, they're saying they don't know what x is, but they know that y is -1. Well, you just go the opposite way. You go to y equals -1, go over to the graph, and then come up to the x-axis, and that gives you what the number for x, the number that will go in the parentheses. Okay, I don't think there's another domain and range problem, but there might be.
Yeah. Can we try and do a solution one?
A solution one, like this?
Yeah.
Okay. Here are the two inequalities. Inequalities means you have to have shading. Now this would be a lot easier if you do this on your own paper first. So I'm going to do that. In fact, I'm going to come over here and do that. Yeah, that's what I'm going to do. So let me look and see what this is. Okay, so I don't have to stress my memory. There. Okay, and we're also going to be finding, well, wait. The first thing you're asked, I noticed, is you're asked to find the vertex, and then you're asked to do the shading, which is kind of backwards, but let's do that first. You've only got two linear inequalities here, which means the line parts, you're only going to have two line parts. Anytime you have two lines, only two lines, they're going to cross somewhere. Okay, y equals x looks like this, and 3 minus x is not that vertical. So we'll say this. Okay, and what we're looking at for the vertex is just that one point. So what we're going to do is, this is all set up for substitution. So y equals x and y equals 3 minus x. Well, y and y are the same letter. So if y equals this and y equals this, then they have to equal each other. So I'm going to say x equals 3 minus x. And then I have to get my x's on the same side of the equation. Negative x plus x is 0, so I'll have 3. Then I'll divide by 2 and divide by 2. So x equals 3 over 2. Now that gives me the x coordinate. I still need the y coordinate. I could use this equation if I wanted to, but this is so much easier. I mean, y equals x. You can use either equation. This is easy. If y equals 3 over 2, then y equals 3 over 2. I mean, okay. If x is 3 over 2 and you have y equals x, well, duh, y is going to equal 3 over 2. So that's your vertex right there. Okay, and you don't even have to know what the two lines look like to be able to do that. All of the variables are to the 1 power, which means you don't see it. You don't see the power. And when that happens, they're straight lines. Straight lines are not going to bend around and cross the other line in more than one point. I mean, straight lines are straight, so they never bend around. So you're only going to have one vertex when you have two straight lines crossing each other. Now, let's make a quick sketch what you would do on your paper. Okay, this is just real basic. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. I don't really know how far I have to go to graph these, but I figure 4 is okay. Not going to be exact at all. The line y equals x, I already know. Y equals x. Whatever x is, y is. Whatever y is, x is. So what you're going to have is a line going at a 45-degree angle forever and ever. This is y equals x. But y equals 3 minus x, that one I'm not going to even try to do in my head. Instead, I'll make an XY chart because that's much faster than any other way. I can choose my X's when I do this. X is 0 and X is 3. How about that? If X is 0, you'll have 3 minus 0, which is 3. And if X is 3, you'll have 3 minus 3, which is 0. So 0, 3 is right here. 3, 0 is right here. Notice they're both solid lines. Okay, now what did I not do? I should have waited to draw the other line. But what the heck? I am going to put a red line over y equals x. That would have been better. Okay, so there's the red line. There's y equals x, and we will just kind of get rid of the line part. Woo! Okay. Now, it goes through 0, 0. Remember, I need a test point. I'm just talking about the red line right now. I could choose the test point anywhere over here or anywhere over here. I've got to pretend I didn't already put the black line in. What do I do? How about that? It just appeals to me. I'm going to let 0, 2 be my test point for the red line. The red line is y equals x. If y equals x, then if I make an XY chart, I'm going to have 0, 0, 1, 1, 2, 2, 3, 3. They're going to equal each other. It is not going to be true, going back here, if x is 0 and y is 2, it is not going to be true that 2 is less than 0. Of course, it's not equal to, but it's not less than 0 either. It's greater than 0. So this point gives me a false or just common sense, and familiarity with what y equals x means they have to be equal. They cannot be different. So this is false, excuse me, and therefore I'm going to shade away from the point 0, 2. Okay, now I'm going to let y is greater than or equal to 3 minus x. Why don't I make that green? I can leave it black. What the heck? Okay, now life is easier here on the black line because it doesn't go through 0, 0. I could use 0, 0, but I don't want to complicate life. Look at this, 0, 2 is also not on the black line, so I'm going to use that. I mean, there's no law that says I can't use it. So if x is 0 and y is 2, I'll have 2 is greater than or equal to 3. 3 minus 0 is just 3. Well, you know that 2 is not greater than 3, ever. So this also is going to give me a false. This is my day to get a false. So instead, I'll graph away from the point 0, 2. Got an F for the black line also. Okay, that's all I need to do on my paper because I'm graphing on MyMathLab. So I see where these colors overlap. And I know now that this will be the shaded area. So what you do now is you go to MyMathLab. For each of these lines, like for y equals x, I already did this, didn't I, down there? 0, 0, 1, 1, 2, 2. Pick two of those points to graph, and you'll get this line. And then pick these 2 points or any other 2 points you found to graph this line. And then drag your little paint bucket in here and click. You'll be shading in this area, and it's really a much faster way to do graphing on MyMathLab, graphing inequalities. Okay?
What if we were to find the vertice, not the vertice, the vertex last?
Does it matter? I think we found yesterday or the day before that if I were to put that in first, I couldn't click on check answer. You have to have the whole thing before you can click check answer. So it probably wouldn't matter. You probably could graph it first.
Mm.
And then find the vertex. Maybe. I don't know. Try it. If it won't let you graph first, then find the vertex first. Like
I'm trying to like remember how to find the vertex last. I'm going through my notes. It's making sense a little. You just add them, right?
Yeah, you're just going to work with these two, except with equal signs. You're working with y equals x and y equals 3 minus x. So you could add them. You know, you could do elimination. You could say, okay, yeah, you could say y equals x, y equals 3 minus x. So you'd have 2y equals 3. X minus x is 0. 2y equals 3, you'd get y equals 3 over 2.
And then, okay.
And then if you go back up here, for instance, y equals 3 over 2, and y also equals x. So x is going to be 3 over 2. So you would, you know, it would not be rocket science getting the vertex.
Okay. Okay.
But considering you're doing it on your paper first, you can graph it and then shade it, and then you actually have a mental image there. You won't be able to tell exactly. For instance, this looks like the way I graphed it. It looks like 2, 2. But it's not. It's 3 halves, which is 1.5. It's 1.5, 1.5. So anything you just kind of graph out on your paper is only going to be approximate. Okay?
Yeah, okay.
Okay, we've got 10 minutes. Anybody else have a question? No?
Barbara, have we gone over number 9?
Number 9. Okay. There it is. Number 9. Ooh. So we're going to go out with a hard one, are we? Actually, next semester, you're going to say, wow, that was easy. I don't know. Are you going to take any more math?
I am.
All right. Well then, you'll be calling this problem easy before you know it. This is 9. This was the problem that came before it, so this is number 8. Okay. We're going to be finding the difference quotient f of x plus h minus f of x over h. But I actually think it's easier to do it on the paper here. So I'm going to get black and do it. I already know what f of x is, so I'm going to find f of x plus h, which means I put x plus h in parentheses in for the x. And that equals no eraser plus 5. That was supposed to be a plus. Okay, plus 5, and that's going to equal x squared plus 2hx plus h squared plus 5. Save that. Okay, now that we've got f of x plus h, we're going to write down f of x plus h, x squared plus 2hx plus h squared plus 5 minus parentheses x squared plus 5. Okay. And that will be x squared plus 2hx plus h squared plus 5 minus x squared minus 5. Okay, now we combine like terms. We've got 5 minus 5, that's 0, and x squared minus x squared is 0, and so f of x plus h minus f of x is going to equal 2hx plus h squared. So f of x plus h minus f of x is 2hx plus h squared. And I write it this way only because I know I'm going to be dividing by h. Okay, there you go. So that's how they got their answer right there.
Could we do another one of those just really quick?
Sure. Okay. If I start out with f of x equals 2x squared plus 3x plus 5. And I want to find the difference quotient, so I'll say diff-EQ, which is what people in math call it. They think it's cute. I think it's cute. Diff-EQs. Okay. F of x plus h equals 2 times x plus h squared plus 3 times x plus h plus 5. So this will be 2 times x plus h times x plus h plus 3x plus 3h and then I have to keep working on this. Uh. 2 times 2 is 4. Didn't distribute. Yeah, 2 has to go here, 2 goes here, and 2 goes here. So let's just erase the whole thing and start over. Not the whole thing. Okay, 2 times 2 is 4. So 4hx plus 2h squared. There you go. 2x squared plus 4hx plus 2h squared plus 3x plus 3h plus 5. That is what f of x plus h is going to be. Now I need to find f of x plus h minus f of x. And that will be parentheses 2x squared plus 4hx plus 2h squared plus 3x plus 3h plus 5 minus parentheses the original f of x 2x squared plus 3x plus 5. And so what that's going to do for me, I'm going to start a little more over to the left to have more room. 2x squared plus 4hx plus 2h squared plus 3x plus 3h plus 5 minus 2x squared minus 3x minus 5. And now that all the parentheses are gone, you've got to wait till the parentheses are gone, you can combine like terms. So you're going to have 2x squared minus 2x squared and positive 3x minus 3x and 5 minus 5. So that what you're left with is 4hx plus 2h squared plus 3h. So now we know that f of x plus h minus f of x, after you combine all your like terms, will be pretty short. Okay. And now finally, we're going to find f of x plus h minus f of x over h. And that'll be 4hx plus 2, I'm going to say h times h plus 3h. And I could, well, I just prefer to go ahead and jump to the step, this step right here. And so that the h's cancel out there, h's cancel here, h's cancel here. And so what you're left with is 4x plus 2h plus 3. And that's it. So this one was a little more complicated. The more terms you get, the more complicated it is. The higher the power you go, the more complicated it is.
Thank you.
You're welcome.